So good morning students. Today we are going to read chapter 9, that is Light, Reflection and Refraction. So we can see everything around us. I can see this chalk, desk, benches, walls, tube lights and everything. But when we are in a dark room, I can't see the same objects. Similarly, in the daytime, when sunlight is there, I can see everything around me. But at night, when it is dark, we can't see the objects. What does this mean? This means that light helps us to see objects. But how? How does the light help us to see the objects around us? So to explain this, let me draw a diagram. Suppose we are in a dark room. This is a room and this is a dark room. And here there is a bulb which is not glowing now, which is turned off. Here I have a pencil, any object. For example, I am taking, it is a pencil. And here am I. When it is a dark room, I can't see the objects in the room. I can't see this pencil or any object that is present in the room. But when I turn on the light, I am able to see the pencil. How? Because the light from the light bulb comes and gets reflected from the pencil, and this reflected light which is coming from the pencil reaches our eyes, and when this reflected light from the pencil reaches my eyes, I can see the pencil because the light coming to my eyes is coming from the pencil. Okay? So this is the reason why we can see the objects around us. So let me take a practical example. Here we have a chalk in my hand. I have a chalk in my hand. I can see this chalk now. Why? Because light is falling on it and getting reflected, and that reflected light from the chalk is coming to my eyes. So I can see this chalk. And similarly, everything reflects light that falls on it, and that's why we are able to see that object. But what will happen if I put my hands in between this chalk and my eyes? I will not be able to see the object or the chalk. Why? The reason is the light is still falling on the chalk and the reflection is happening, but that reflected light is not reaching my eyes, and that's why I am not able to see the chalk. Okay? So what is happening when this reflected light can't reach our eyes, we are not able to see this object. Okay? So now we will discuss the most reflective surface which we had already read about in previous class. That is the plane mirror. We know the plane mirror reflects most of the light falling on it. But before starting that topic, let us think what else does the reflection does. The first thing it does, it makes me see the objects around us. Second thing, the reflection makes the image. In a mirror, we can see an image of everything. Suppose I have a mirror in front of me. My name is Rahul, and in the mirror, I have a same to same image of mine. There is another Rahul in the mirror, which is my image. How is this happening? So sir, this is very simple. No, this is not very simple. We have not thought in that way. I have seen in many discovery channels and all, like they put a mirror in the jungle, a big mirror in the jungle. Suppose a monkey is coming or a bear is coming and see their image, but they don't know that that is an image. They think that the image they are seeing, what they are seeing is another animal. So they get confused and they try to attack them but can't reach them. Okay? So here we have seen from the very childhood that okay, this is a mirror and our image is formed. So we don't think like that. But it is a very complicated, not complicated, but it is very interesting thing that how same to same Rahul is forming inside the mirror. Why that Rahul is forming inside the mirror? Okay? So let us see this. So suppose here it is a plane mirror. We draw mirror like this. I will explain how a mirror is made afterwards, but let's see how an image is formed inside a mirror. Okay? Now, suppose we have a point object in front polished or colored like this, and this is the front side of the mirror. An object is kept in front of the mirror. Point object. For now I have taken a point object. Now, as I have said here, that when the light from an object reaches our eyes, we are able to see that object. Yes or no? So in this case, the light will fall on this object, yes or no? And it will go towards the mirror, and this is called incident light. And as we have read in the previous classes that this is incident light, this is point of incidence, and this is reflected light. And as we have read that angle of incidence is equal to angle of reflection. Yes or no? So this light is coming from, this light ray is coming from here and getting reflected there. This is the incident ray, this is the reflected ray. This is the normal which we have already read in previous classes. This is angle of incidence, this is angle of reflection. Now, suppose a second ray is coming like this. This is the angle of incidence. And here, angle of incidence is 0 degree, because this is the incident ray and the normal is also upon this. Both are coinciding with each other. So the angle between the incident ray and the normal is 0 degree. So if angle of incidence is 0 degree, angle of reflection will also be 0 degree, and this light ray will just come back in the same way. Now this ray is going in this direction, it will go in this direction. This ray is going in this direction. They are never going to meet. They are never going to meet. So what we do? We just, it appears that this object, this light is coming from this point. It appears to my eyes that this point, this light ray is coming from this point. Okay? And this image is called the virtual image, because in real it is not made. So this is called virtual image. Okay? So as we have seen that the light ray after reflection is not meeting in the real life, as we have drawn imaginary light backwards, so the image is forming behind the mirror. So this image is called virtual image. And in plane mirror, one of the more characteristics of image form is that the distance of the object from the mirror, means object distance, is equals to image distance. Object distance will always be equal to image distance. Okay? Now, so what are the characteristics of the image that is formed by a plane mirror is: first, object distance is equals to image distance. Second, it always forms a virtual image. Third, it always of the same size as of the object. Okay? And fourth, it is laterally inverted. What is the meaning of lateral inversion? Lateral inversion means, suppose this is a mirror and we are writing a letter E from here. So it will look like this in the mirror, and this is called laterally inverted. Means the left part becomes the right and the right becomes the left. Okay? If you will write A, there will be no problem. If you will write B, it will become like this. Now the question is, why does this happen? Why does the image formed by a plane mirror is laterally inverted? So it is nothing. It is due to the object distance is equals to image distance. Let us see, this is E. Let us see, this is E. So this point is this much far from the mirror. So it will become image in this point. This part will become here. And as this is in the with more distance with the image mirror, this point will become here, and the E will look like this. So that's why the right becomes the left and the left becomes the right, which the phenomenon is called lateral inversion. Okay. Now this was all about the plane mirror, but this was just an overview of what you have already read in the previous classes. This part is not important for class 10, because in class 10 we will not read about the plane mirrors, we will read about the spherical mirrors. So mirrors, we have read mirrors of two types. One is plane mirror that we have already discussed in previous classes and now also. And now another type of mirror is there, spherical mirrors. What are spherical mirrors? The plane mirror is usually plane, okay, it forms in one plane. But when suppose we have a football made up of glass, we have a football made up of glass, and I will cut just a part of it. Okay, so how will it look? Like this? Yes or no? It is a glass, means light can go from one part to another. It can go through it. Okay, so if we will do a process called silvering or polishing in one side, it will become a mirror, and then this mirror will be called as concave mirror. This is an example of spherical mirror, and this is a concave mirror. Concave mirror. When we will do the silvering in the curved part and the light is going in the inner part. Now, if I will take the same spherical mirror and polish it in this side, doesn't it will look like a curve which is curving outward? This is called convex mirror. Convex mirror. Okay. Now one very interesting thing is that these mirrors do not act like the plane mirror. In the plane mirror, we have seen that the size of the object is equal to the size of the image. But these mirrors has many different properties than the plane mirror just due to their shape. And this is convex mirror. So now we will see about concave mirror in detail, that how the image is formed, what is the properties of the image that is formed. Okay, so now we will see, now our topic will be the topic image formation. Image formation by a concave mirror. Concave mirror. Now we have seen that concave mirror looks like this. Concave mirror looks like this. But for a proper diagram, we will use the rounders that you will have. Okay, we'll use it. This is our concave mirror. Okay, and here I have kept it. So this is our center. This is our center. Now, as I explained about concave mirror, that a concave mirror is a part of a sphere. A concave mirror is a part of a sphere. So that sphere would have a center. That center we represent by C and is called as center of curvature. Means this is the center of this concave mirror. We call it center of curvature. We call it center of curvature. Now, the midpoint of this concave mirror is called pole, P. We call it pole, capital P. Okay, and we do joining. 0 to, okay, so this line joining the center of curvature and pole, this line joining the center of curvature and pole is called principal axis. This line is called principal axis. This line that we have made by joining center of called as principal axis. This line is called principal axis. Okay. Now this is 45 centimeter. The distance from center to the pole means the radius. If it is a circle and this is the center, then this distance we call radius. Here it is called radius of curvature. This distance is called radius of curvature and it is represented by r. So here radius of curvature is 45 centimeter. Here radius of curvature is 45 centimeter. So we take a point in between center of curvature and pole. A point between center of curvature and pole is called focus. If this is 45, then we will do a 22.5 here. Here a focus will be there, and this point will be known as focus. This point will be known as focus. So I am just repeating again. This is the concave mirror. The center of the concave mirror, the midpoint of that curvature is called pole, and the center from which this concave mirror is cut out. This concave mirror is a part of the sphere. The center of the sphere is called center of curvature. The distance between center of curvature and pole, this distance is called radius. So it is radius of curvature, and a point is between center of curvature and pole, that is known as focus. Okay. Now to draw a ray diagram, we have certain rules. Okay, and we have to see what the rules are. The first rule is, if suppose a ray of light is coming parallel to principal axis, a ray of light is coming parallel to principal axis. Let us suppose this ray is coming parallel to principal axis. So after reflection, it will pass through focus. After reflection, it will pass through focus. Am I understood? This is the first rule. If a ray of light is coming parallel to the principal axis, then after reflection it passes through the focus. After reflection it passes through the focus. Now to make the diagram clear, I am just rubbing these names. Okay, we know what is C, center of curvature, focus, and pole. This line is called principal axis. Okay, in this diagram, what we have made now, the radius of curvature is 45. The radius of curvature, the radius is 45 centimeter, and the focal length F, this is known as focal length. The focal length means this distance is of course the half of the radius of curvature, 1 by 2. So it is, focus is r by 2, and that is 45 by 2, this is 22.5 centimeter. Okay. Now, like we have drawn the ray diagram of plane mirror, that there was a point object in front of the mirror, and that was, we have seen that how the image is formed. Similarly we will draw in the concave mirror. If a object is in front of the concave mirror, then how the image will be formed. Okay, but before this we have to learn the 4 rules. The first one is, if the ray of light is coming parallel, it will go through the focus. It will go through the focus. Now the second one is, if the ray of light is going through the focus, is passing through the focus, if the ray of light is passing through the focus, if the ray of light is passing through the focus, then it will go parallel. Then it will go then it will go parallel to the principal axis. Okay, if the line is going through focus, if the ray of light will go through the focus, then after reflection it will go parallel to the principal axis. This was the second rule. This was the second rule. Okay, now rule number 3. Now rule number 3. Suppose a ray of light is going from center of curvature. A ray of light is going or passing from center of curvature. If a ray of light is coming from center of curvature, this line is coming from center of curvature, okay? Let us extend this line towards backward. So this is a ray of light coming from center of curvature. Then after reflection it will go in the same direction. It will not change its path, it will go in the same direction. Okay? This is the third rule. This is the third rule. Okay? Now suppose if a ray of light is directly coming to the pole, if a ray of light is directly coming to the pole, then it will go at the same angle from the principal axis. This is incidence angle of incidence. It will go from the same angle from which it had come. So how will we make it? We can draw it like this. If we don't have a protector, we can do like this. We can just above focus, we can take a point which is, this line is 5.3 centimeter. Okay, so behind it we can write, we can take a point 5.3 centimeter, this point. So when we will join this point with this point, both this angle will become equal. Both this angle and this angle will become equal. So this is the fourth rule. This is the fourth rule. That when a ray of light goes to the pole, then after reflection it goes from the same angle that it had incidented with principal axis. Okay? Now we have learned the four rules. Now we will see how an image is formed in a concave mirror. Okay? So in a concave mirror, suppose we will make a concave mirror. Okay? We will make a concave mirror. Here is the center of curvature. Okay. Here it is the center of curvature. ये करना है. So we will make the principal axis. We will make the principal axis. This is the principal axis. This is the center of curvature. This is the pole, and this is also 45. So we will take the focus at 22.5 centimeter. This is the focus. Okay. This is the focus. Now let us take an object of 10 centimeter, object of height 10 centimeter, and it is kept behind the center of curvature. Let's see where the image of this object is formed in the concave mirror. So first, a parallel ray of light will come. A parallel ray of light will come, and if it is parallel, then as we have learned in the first rule that it will pass through focus after reflection. It will pass through the focus after the reflection. Okay? So it is passing like this. We can also extend this line as our scale is not that much bigger. So we can do like this. And this is the reflected light. Now, in the second case we have seen that if it goes through the focus, suppose here it is, here the focus is, just check it is in the line, and we can draw like this. Okay, so it is crossing through the focus. So now it will go parallel to principal axis. So these 2 points, these 2 rays are meeting at this point, and these 2 rays are emitted from the head of this object here somewhere. So wherever these 2 rays will meet, it will again form the head of the object. It will form the image where the head of the object will be formed. So the object will look like this. So we can see that this image form is formed from the actual intersection of the rays. Yes or no? So this image is called real image, and of course we can see that this image is also inverted image. So the object when placed beyond the center of curvature, the image is formed between center of curvature and focus. It is real and inverted, and it is diminished in size, means its size is smaller than the object. The size of the object is this much and the size of the image is this much, means the image is smaller in size. Okay? So this is one of the diagrams of all the diagrams where the object is kept beyond the center of curvature and the image is formed between center of curvature and focus. Like this, there are 6 diagrams of concave mirror where at first we will keep the object in infinity, then we will see the properties of the image and where the